Hello, everyone, and thank you for joining us for a session of Ask a Chemist. My name is Sandra, and I'm a fourth-year chemistry student at Oxford, doing a project in theoretical chemistry. And today we're gonna have Brian Balmer as a guest, which I'm going to present in a few words. Brian did his chemistry undergrad at Oxford at Oriel College, and then moved to the materials department at Oxford to do a PhD. And now he's working for Frost and Sullivan, but I'm going to let him say more about what he's doing right now and how his journey has been since he left Oxford until now. Brian, the floor is yours.
Great, thanks, Sandra. So let me see if I can share a few slides for you. Can you see that on your screen now?
Yes, we can.
Fantastic, great, thank you. So yeah, no, thanks for inviting me for the opportunity to take this session, Sandra. I've got a few slides that I'll run through now, just to give you all a bit more background on myself and what I do at Frost and Sullivan, before we move on to the actual Q&A session. So, as Sandra said, I did my chemistry degree at Oriel back, started in 1992. I actually did my fourth year, my part 2 year in materials department as well. So I moved over to there for that and then stayed on in the materials department for my PhD as well. Interesting experience in the part 2 because you wouldn't realize the amount of bureaucracy involved. Even the type of binding you're meant to use on your part 2 thesis is different in materials and in chemistry. So if you do decide to move for your part 2 year, then bear those things in mind. When I did my PhD, I had some really useful experiences that stood me in good stead for my future career with a job. When I did my DPhil, I went on a residential course, which was a week long, I think, on building up business skills for yourself, which was a really interesting experience. And I also got to go to 3 technical conferences as well on my subject of my PhD, which was superconductors, as it says on there. When I finished my DPhil, started looking around for a job. Wasn't sure what I wanted to do initially. Just that I didn't want to stay in a lab job at that point in time. I think 3 years of DPhil was enough for me in a lab. But I still wanted to use my skills as a chemist. So, I did apply for some generic consultancy jobs with, people like McKinsey and so on. But my heart really wasn't in that, I don't think. I applied for some jobs in industry, and sort of same thing there. Some were potentially a good match, but then I came across Frost and Sullivan, which is a consultancy company, but one which very much is focused around groups with industry expertise. And I joined the chemicals team, so that was perfect. It was a way to get a career in a sort of business side of things, but one that was very much using my chemistry knowledge as well. So I joined them as a junior market analyst in 2000 and have been there ever since, 22 years. And now I manage the global chemicals research team here for our company. So that's me. A little bit about Frost and Sullivan. As a company, we've been around for 60 odd years now, and our remit as a consultancy company has always been to help our clients achieve growth. That's been our sort of core USP since the start. And we've done that historically by producing market forecast reports. So the main things I'm researching when I look at a particular market is how big is that market and how fast do we think it will grow in the future. Now, as I've highlighted on the screen there, I've underlined the word sustainable because we are increasingly focusing on helping our clients to achieve sustainable growth, because just growth for its own sake, and if we talk about economic growth, isn't necessarily that sustainable. And As an individual, I'm very passionate about sustainability and environmental causes. So sometimes I do find it difficult to sort of marry that with the fact that I work in a career that helps big chemical companies, people like ExxonMobil and Shell, to grow their businesses even bigger. So increasingly, we're doing it in a way that helps them achieve sustainable growth, and I'll sort of come on to how we do that in a little bit. But when we look at the chemical industry, as I see it, there are some really big trends in the industry at the moment, and I'll come on in a little bit in a couple of slides. Let me just check I've got it further on down. Yes, I do. Important to think at this stage to define what I mean by the chemical industry. And I think for a lot of people who study chemistry in the UK, their career ends up going more towards, say, the pharmaceutical industry. So you will work in drug development for a pharmaceutical company, which for us in Frost Sullivan, pharmaceuticals is actually part of our healthcare practice. That's a separate thing. I work for industrial chemicals companies. And we look at that side of things, these are the big trends that we see. So some of it is about, the single biggest product that our clients are asking about most at the minute is battery materials. So what chemicals, what materials do you need to make a lithium-ion battery for electric vehicles, because it's such a high growth sector at the moment. And in terms of trends within the industry in a more general sense, then the industry is going through a massive digital transformation, more use of digital technology within the chemical industry. But obviously sustainability as well is, one of the biggest topics in the chemical industry, for a number of reasons. We use fossil fuels as our primary feedstock. We want to reduce that. Things like safer chemicals and health and wellness are also key trends, because consumers want to live healthier lifestyles, especially as a sort of reaction to the COVID pandemic we've just had. And there's always been a focus on trying to make chemicals safer as well. And, that's a big aspect of what we do as well, helping our clients to do that. So to come back to this question I had posed to myself, how can I help big chemical companies to grow even more, whilst also being true to my beliefs around sustainability and environmental causes. This is a slide that I've used it in presentations myself before, actually, for our clients and so on, and I thought it summarized it quite nicely for here now as well. So I created this just over a year ago. So things have obviously moved on since then a little bit as well. We've got COP27 happening in Egypt right now, but it still serves its purpose. If we start down here in the bottom left, what is the big issue in the world today? Climate change is probably the biggest issue we have. So there's sort of up until a couple of years ago, there were still a lot of climate change deniers out there, but that has changed in the past few years, and I think pretty much everyone, with the possible exception of Donald Trump, believes that it is an emergency now that we need to deal with. How do we deal with that challenge? Well, there are a number of ways of doing that, and it was interesting to see people starting to comment on the fact that certain concepts like circular economy concepts can be really important ways of reversing climate change and stopping what we are doing to the climate. So when we have a circular economy, we do not use raw materials that cannot be replenished. So we use only renewable raw materials. And again, that has sort of parallels in the natural world as well. And in reading David Attenborough's autobiography last year, he drew a really interesting parallel, which I thought was very interesting. And what he was talking about at this point in the book was the Amazon rainforest, and the fact that the Amazon rainforest has been there for millions of years. It hasn't grown outside its own area. It doesn't require any unsustainable external resources to keep it going. So in that sense, it's its own circular economy. But can you still achieve growth within that Amazon rainforest? Well, yes, of course you can. It's an incredibly dynamic ecosystem. Different animals and different plants are succeeding at different points in time throughout those millions of years. So you can still have a finite system that is nevertheless extremely dynamic. And that's the sort of inspiration I wanted to take to what I do at Frost & Sullivan. So I can still recommend to clients that they can be incredibly dynamic as companies, but in a way that doesn't require additional external resources and doesn't have an unsustainable impact on the planet as well. And the example on the bottom right then is just, one of a number of people starting to sort of showcase that companies can achieve commercial success, as it says, without causing more damage to the planet. And just sort of final message in the center then as well is the whole concept of the fact that you can run a business in a way that, yes, okay, you could achieve like zero carbon as a target. You can have no impact on climate change, but even better than that would be to have a positive impact on the world as you run a successful and profitable business. And in 2021, there was a lot of talk about regenerative farming and the fact that agriculture could operate in a way that actually regenerates the natural world rather than degrading it. And really last year we saw a lot more acceptance of that as a concept. And again, potentially that's something other industries like the chemical industry can learn from as well. So that's a sort of summary of how I see me being able to continue to help chemical companies to grow, but in a way that doesn't have to be damaging to the environment. And on my own personal journey there, just wanted to highlight a few of the books I've been reading this year to get my head around this concept. I've already mentioned David Attenborough's autobiography, which you can see on there, and a couple of other books. So this one here, The Dawn of Everything, I'm just started reading that one now. Really interesting book, but yeah, quite a controversial view for some people potentially. And then on the right hand side, Thich Nhat Hanh, very famous Buddhist monk, and his thoughts on how everyone as individuals can play their part in helping us to save the planet. We can't just rely on governments legislating and telling us what to do. We all as individuals have a role to play as well. So yeah, doing a lot of personal reading around this subject, and hopefully that's helping me in my career as well. So to come back to the subject of who we serve as clients within the chemicals team at Frost & Sullivan, our target clients are the main global chemical companies, as it says on there. So I don't look so much at pharmaceuticals. As I said, that's our healthcare team that does that. But to get a sort of benchmark of who are the big chemical companies out there, the sorts of companies we would like to have as our clients, I've used a magazine, ICIS Chemical Business. Every year they publish an updated list of the top 100 chemical companies. So I've just shown, well, the top 60 is what I could fit on the slide basically here. But BASF over in Germany, Sinopec in China, Dow is based in the US. It's a global industry, and all of these companies, even though they are based in a particular country, will all be operating globally now. And INEOS, real success story of the UK chemical industry. Jim Ratcliffe started out by buying some of the old unloved assets from people like BP when they wanted to get out of the chemical industry, and he's made a real success of the business. And obviously he owns an awful lot more now than just a chemical company. So you've got the INEOS cycling team in the Tour de France, etc. as well. So those are the sort of companies I think about when I think about the role I play in working with the chemical industry. The next question then, I guess, is how does my team and what we do on chemicals fit into the bigger picture of my company, Frost & Sullivan overall? And I illustrate it, as you can see on the screen here. So we have 12 practices across Frost & Sullivan overall. The two big boxes on the left-hand side here sort of group 10 of those practices into 2 broad areas. So we are one of 5 what I would call enabling practices, which are these are things that all other industries will need in order to run their business. So when you look at the vertical practices, so the downstream industries, if you want to make a consumer goods like a packet of breakfast cereal, or if you want to make a car or a medical device or an aeroplane, or if you want to generate electricity and be an energy utility, you need chemicals, and you need, in most cases, you need industrial factory equipment, you need a supply chain, etc. So the top 5 here are enabling practices because they allow the downstream industries to operate. And we are one of those. So a lot of the commentary that we provide in our research is to say, what's happening in the automotive industry? Are cars changing? How fast are they moving from internal combustion engines to electric vehicles, etc.? And what knock-on impact will that have on the plastics and the coatings and the lubricants and everything else that go into the production of a car? So by having these colleagues downstream, that provides us with a really good platform so that we can go to chemical companies and say, yeah, we know what's happening with the car industry, and we can help you translate that into a sort of knock-on impact for you as a supplier of chemicals into that application area. Then on the right-hand side, we've got a couple of other practices, which I've called foundational practices. And as I said at the start, our business exists to help our clients grow. And in order for all companies in any industry to grow today, they all need 2 things. They need a strong innovation pipeline, so they need R&D, and they need a strong sustainability message as well. So we have 2 other practices that look at these 2 aspects and help clients across all industries to understand how sustainability factors will be evolving over the next 5 to 10 years and what new products are being developed as well. So those are the other 2 aspects. So that's kind of how I fit into the bigger picture of Frost & Sullivan overall. Just a quick word about my team then. So I manage the chemicals team, and we divide ourselves up into 5 sort of mini program areas. So we have a team of analysts that looks at each of these individually. So I myself, even though my PhD was in ceramics, I've ended up now managing the polymers and composites program, in addition to managing this whole chemicals team overall. So my analysts will produce reports on things like engineering, plastics, composites, packaging materials, 3D printing materials, etc. So we've chosen these 5 areas for a number of strategic reasons, but in the knowledge that we aren't covering everything. I have beside my desk here my dictionary of industrial chemicals, which is, I don't know, there's over 10,000 entries in it, everything from benzene to something much more complicated than that. 10,000 commercially available chemicals on the market. We couldn't possibly write a report on every one of those. So we have to just decide where to focus. So there are some things we haven't done so much on. Electronic chemicals, for example, is one. There's an awful lot of chemicals used in the production of silicon chips. But actually we might start doing a bit more research on that next year as well, because chip shortages and so on have been in the news so much that actually there is a bit of a need, I think, for us to provide some commentary on the future of that industry and how that will affect chemical companies who supply chemicals for that area. And then just quickly as a last slide, wanted to emphasize this and the fact that whenever I look at the work that we do in the chemical industry, then a value chain perspective is a crucial one to have, and it helps me to map out the companies that are out there and what they do across all of the program areas we have. So I haven't shown petrochemicals on here because it's different. That's more upstream anyway. But the other 4 programs we have, take case and construction materials, for example. So case stands for coatings, adhesives, and sealants. So, if you wanted to go if you wanted to repaint your house, you would go to B&Q, you'd buy a tin of paint. That tin of paint would have been made by someone like PPG or Akzo Nobel, or I think Jotun, who now owns the Crown brand, for example. So they aren't really chemical companies. They don't do any chemistry. They formulate. So they buy chemicals and they mix them together and put them in a tin. Now it is more complicated than that, but basically that's what they do. They buy their ingredients from chemical companies, people like BASF, Perstorp, Evonik, etc., who make the resins, the pigments, the additives that go into that formulation. And for us as a chemicals practice, we try to meet the needs of both of these two types of companies as clients of ours. And then what happens to those products afterwards? Well, they get sent to companies who do something with it. And so, for example, if you are, if you take polymers now as an example, chemical companies make polymers. Those polymers are mixed with pigments and additives, etc., by a compounder. That then gets supplied to a company that owns an injection molding machine who will mold a plastic part out of it. And then that plastic part might be put into a car or a medical device or turned into a window frame in a house or something like that. So that's the sort of downstream side of the value chain. And for each of our different program areas, you can see this orange line going round as to who we would classify as a company that's part of the chemical industry. And we would include people like PPG and Henkel within that. And then companies who are sort of outside of that industry, so downstream from us, like the FMCG industry, Nestle, Coca-Cola, etc. So that's what I wanted to say. I've got a few other slides that I can refer to if necessary, depending on what questions come up. But yeah, that's my introduction. Over to you, Sandra. Do you have any questions coming in?
Thank you very much, Brian, for your presentation. That was really, really interesting. And now we will open the Q&A session for anyone that would have any questions for Brian. But just to break the ice, I would ask the first question, namely, do you think a background in material science is necessary to be able to work for a consultancy company like Frost and Sullivan, or you think you may have any different backgrounds? And also, do you think that a business course such as the one that you've done was also a necessary prior experience to this job?
Yeah. Yeah, no, good questions. In terms of the material science side of things, I don't think that was critical. As I said, my DPhil was in ceramics, but I've ended up managing the polymers team. As it happens, I did write a report on technical ceramics 3 or 4 years ago for our company. I'd been wanting to do it since I joined, but it was never really sort of commercially viable, and our core client base wasn't in that industry. But I always said to them, I'd love to do a report on ceramics if you'd let me. So no, material science wouldn't necessarily be useful. When I look at the analysts who work for me, a lot of them actually come from backgrounds either doing chemical engineering or especially in some countries where we have analysts, like in India, a lot of them will do polymer engineering as a degree, actually. So we do get a lot of polymer engineers coming in and joining us as analysts. But certainly for my team, the majority of our analysts have some sort of chemistry background anyway, because when you talk to chemical companies as clients in my role, they much prefer talking to people who can talk their language. Some of the other practices in Frost and Sullivan that I showed, like ICT, healthcare, etc., you can have a more generic background. You could have done a degree in marketing or an MBA, business studies, and you could be an analyst for those industries. But it's very hard to be an analyst for chemical companies without at least being able to know that benzene and toluene are different molecules, for example, different molecules. Your other question then, you were asking about the business course that I did. No, I thought that was really valuable, actually. Partly just I think the two things that stick in my mind that I learned there was how to work as part of a team, in a very general sense, but also we sort of sat down and we did some profiling of our personalities individually. So that was a great thing for me to be able to talk about at interviews, was the fact that well, I can't remember the name of the actual scheme they used, but I was a plant. So a plant is someone whose personality is to think of ideas. So you plant ideas, and then other people in the team have other roles. So there are other people, completer finishers, who will take the ideas and actually make them into something viable. You have people who are just good organizers, who can be the project manager in the team, and you need someone from all of these different skill sets together to make a good team. And that's, most businesses work in teams. So yeah, knowing I was a plant was really useful, because it also allowed me to understand when I had to rein myself in and think, okay, it's time to stop firing out random ideas to people. We need to actually just get on and decide and do something now. So yeah, no, some really good development in terms of my awareness of my own skills came from that course.
I understand. Thank you very much. Someone says, thank you for your presentation. Is there something you've been working with a company on lately that you're particularly excited about from a sustainability perspective?
Oh, good question. Yeah, I've got a couple of studies I'm working on at the moment that I really need to get finished, actually. I've been doing some work on sustainable construction materials, which really broad subject. But it's one of those ones where it's just really exciting to see that a lot of companies are doing things to try and make their products better. So yeah, in that study, we're just looking at all of the main materials used to construct buildings. So steel, brick, cement, things like that. So, the cement industry is even trying to do something, because it's the biggest industrial emitter of CO2, I believe. So, they're looking at alternative ways to bring down their CO2 footprint. So that's been a really interesting subject to look at. In terms of more specific things I've been working on, it's also, yeah, no, it's just a real eye opener doing what I do. And that's why I think I've been with the company for 22 years, is that you're always learning new things. One of my analysts is working right now on a report on the materials used to make photovoltaic solar panels. And yeah, it was a real eye opener just how complicated it is, and how difficult it is to find the information you need. You get experts out there on solar panels who can tell you how many solar panels will be installed in Saudi Arabia, in the UK, in France, around the world. But you ask those experts, well, what's that solar panel made from? They're like, oh, I have no idea. Good question. So that's what we've been trying to find out. And actually, it turns out that the production of a solar panel is itself pretty bad for the environment. The amount of energy you need to turn sand into hyperpure silicon, which is what you need to make solar panels, really energy intensive. So the carbon footprint of the industry is still quite high. So they still need to do quite a lot of work to bring that down. So yeah, no, it's just always finding out new stuff, even 22 years later, and that's what keeps me excited about the job, I guess. I'm a chemistry nerd at heart.
That's great. Someone also asked, what appealed to you about consultancy work when you had completed your PhD?
Well, yeah, I loved doing my PhD, but I kind of decided that working in a lab wasn't for me. I did apply to a couple of jobs in industry, so actually doing a PhD in superconductors. At that time, there was a company, 2000, Nordic superconductor, who was trying to commercialize the ceramic high temperature superconductors over in Copenhagen. So I went over for an interview with them, didn't get the job. And yeah, went around a few other chemical plants in the UK looking for jobs in various areas. But as I said, it didn't really appeal to me personally. As you many in the audience probably know, when you do chemistry at Oxford, a lot of people end up going to big consultancy companies in London, the city. But that didn't really appeal to me anyway, even though I got through to the final round of interviews for a couple, I think Bain or someone like that. I can't even remember now. But again, didn't get any offers, and then saw Frost and Sullivan and thought that suits me nicely. But we actually do a lot of work with the big consulting companies. So when they when they come on to help with a big M&A deal or something, and they need industry knowledge for the due diligence, they will come to us and we will provide them with the actual market information they need as part of the due diligence process. But yeah, a lot of chemists from Oxford end up going into the sort of big consulting companies, don't they?
Yeah. And also someone asked whether the companies that you've worked with have been receptive to growth via sustainability.
But yeah, no, that's a very good question. I have to choose my words carefully here because this is going public afterwards, this presentation, so I can't be too scathing about some clients. But yeah, there are some oil and gas companies who probably aren't quite on board with the sustainability message yet. I'm still trying to make my mind up as to who I believe. And part of the challenge we see is the same challenge we see across society overall. It's very polarized at the minute. You look at the US elections, you look at other things in the world, and the world is very polarized in people's views. You've got people who are climate change deniers, other people who think it's the one thing humanity should be working on. And the people commenting on these stories are likewise very polarized. So when we look at the kind of public perception of the chemical industry and its sustainability, I want to have sympathy for people like Greenpeace, and I want to be behind them, but for me, they go overboard with their environmental message. They put out messages, all chemicals are toxic, all plastics should be banned, and that's not helpful, I don't think. But at the same time, I read our industry publications. So there's one in the US called Plastics News, I think it's called. And so it's a journal for professionals who work in the plastic industry, and they're the opposite extreme. So they refuse to accept any suggestion that plastic should improve its environmental footprint in some way. They'll always try and find a positive spin for the industry as it is today. So I try to be in the middle somewhere, but there's still a lot of polarization in the conversations that are going on in this subject. And yes, there are projects I do. So maybe just again to explain, within Frost and Sullivan, we have two sides to our business. So one side produces market reports, which we publish and we sell to clients through a subscription model, and I manage that side of the business. So you could call that the research side. The other side is our consulting side, where clients will come to us and we do one-on-one consulting projects just for them. And I've had to work on some consulting projects for clients where they basically said, look, we're an oil and gas company. We want to sell more oil and gas. Tell us how to do that. And, sometimes we have to do those projects because we need to make money. But yeah, it kind of goes against my my own beliefs a little bit to work on those ones, but thankfully they are in the minority now.
Thank you, Brian. Someone asked, what did you enjoy about your research at Oxford, and do you ever get to apply it in your current work?
Yeah, well, as I said, it took a long time to persuade my company to let me write a report on ceramics. It was like 16 years after I joined, I finally got to do it. But it's been useful in other ways anyway, for sure. What did I enjoy most about the DPhil? I had sponsorship, so Merck sponsored my DPhil. At that time, they actually had a pilot plant to produce the powders that I would then use. So I would make superconductor tape. So I would deposit this powder onto a silver wire substrate to make a superconducting cable. And Merck had a sort of spray drying facility that they would use to make the powders in a pilot plant down in Poole in Dorset. So the sort of 2 summers, end of my first year and end of the second year of my DPhil, and I went for a few weeks down and actually worked in their pilot plant facility, making the powders that I would then spend the next year turning into cables. So no, that was really interesting because I got to experience a workplace a little bit, actual chemical plant. And I got to spend 2 Augusts working by the beach in a factory that closes at 4 o'clock in the afternoon, so you could go down the beach after work, which was brilliant. Yeah, the river in Oxford isn't quite the same. Going to Parsons Pleasure isn't quite like going to Sandbags Beach in Dorset.
Someone says, I think you work on antibiotics. What does your role involve in this sort of field?
Yeah, so anything we do on antibiotics would be more the remit of the healthcare team rather than my chemicals team. I have put some commentary out there anyway, and I track a little bit on what's happening in the healthcare space. One of the program areas in my team, as I said before, is nutrition and wellness is one of our program areas. So they do research on all of the ingredients that go into our food, the sort of non-drug ingredients for pharmaceuticals. So we do research on excipients and the other ingredients that go into a drug formulation. So you're looking confused there, Sandra. So if you take a paracetamol tablet, it's got paracetamol, but it's also got calcium carbonate as a filler. So the fancy word for the filler is an excipient because they play an important role in deciding how quickly that drug is absorbed into your bloodstream, into your body, controlled release mechanism, etc. So so we do research on those. We also in that team look at animal feed and agrochemicals, etc. in general as well. But yeah, antibiotics, obviously big subject both in the agriculture space and also for humans as well. And antibiotic resistance is a huge topic. And how do we get around this issue of antibiotic resistance? That's definitely something the healthcare team looks at more than me. But I'm also really interested just in some of the alternative therapies that are coming out now as well. So a lot of the discoveries being made, not just on the human genome, but on what happens in the body to turn on and off which genes fire in your body, depending on environmental conditions. So your DNA doesn't tell you everything about you. How that DNA is expressed is very much determined by environmental factors as well. So this is a whole new industry that's just sort of starting up today. And the ramifications that has for our resistance to disease, etc. as well. So I'm hopeful that some of these other alternative technologies will mean we can stop taking traditional antibiotics so much. And yeah, and on this sort of agriculture space, well, I try to buy organic food because I prefer to buy meat that hasn't been given too much antibiotics, etc. So that's my personal stance on that.
Thank you very much. Are you optimistic about the progression of sustainable growth with the companies you work with?
Good question. Yeah, I think I am actually. So just last month was the K Fair. K is it's in Düsseldorf in Germany. So K stands for Kunststoffe, which is the German word for plastic. So this is the big global trade fair for the plastic industry, and it's every 3 years. And up until the last one 3 years ago, there was a little bit about circular economy and recycling, etc. But I went there last month, and every company there had products on their stand to show these are the polymers we now make from bio-based feedstocks. These are the products that we now make from a recycled feedstock. And these are the products that we have designed to be more recyclable. So all of a sudden, it was everywhere. It's just this year, it's gone from being, yeah, that's something we should think about in the future, to almost being mainstream now and something everybody has to do. So I was really heartened to see that change in how companies are doing that now. So yeah, no, things are genuinely happening now. It's not just talk anymore. They are doing things. There are still challenges. One of them is with the energy consumption in the chemical industry. I did a project last year on decarbonisation trends in the chemical industry, and when you look at all of the carbon atoms coming into the chemical industry, I was quite shocked to see that only half of them end up in the products that they make that we buy, the plastic or whatever. The other half of those carbon atoms gets burnt and turned into CO2 for energy. So the actual energy requirement of the chemical industry itself is vast. And they'd been doing a lot of work. Evonik was a really good example. Evonik runs its own combined heat and power plants. So CHP is a technology to generate electricity and heat in a single natural gas-fired burner. So when we have gas-fired turbines for our national grid electricity in the UK, they generate electricity, but the heat is considered waste. Whereas if Evonik generates its own electricity with these plants, it can also capture that heat and use it where it needs heat for endothermic processes. So they'd made great progress in reducing their carbon footprint by just getting more efficient with their use of energy. But they did so by becoming very reliant on natural gas. And Germany, at the minute, has very little natural gas available for people. So they've had to go back to just putting more coal into their plants as a stopgap at the minute because of what's happening in the world this year. And I think they didn't want to, but in order to keep their business running, they've kind of decided it's something they'll have to do. And hopefully that situation will resolve itself soon.
Yeah, that's true. Someone says, thanks for your wonderful presentation. A lot of my classmates are planning to apply for material science and natural sciences in university. Could you please talk about what are some non-academic requirements for students interested in these courses to be successful?
Oh, wow, that's taken me back a few years now. Yeah, I remember when I came to Oxford to do my interviews when I was a sixth former in school. I ended up studying at Oriel. I actually applied to Keble, but didn't get accepted there. And yeah, no, I wasn't quite prepared for the first interview with Keble. So they asked me a couple of questions, and I should have had an answer at the tip of my tongue, but just sort of froze in the moment. So maybe when I came to speak to Keith Prout, who ended up being my my tutor at Oriel, then he was maybe a bit more sympathetic to someone who'd come from a school that didn't send a lot of people to Oxford and wasn't used to this whole concept of an interview like that. And having had one interview, I was sort of better prepared to answer questions as well. So they asked me in Keble, what sort of books are you reading at the moment? And I had an answer prepared because I had just been reading the story of Crick and Watson and their discovery of the structure of the double helix, the DNA helix, and totally forgot to talk about that when they asked me that question in the interview. And I just started burbling on about science fiction books that I read that have no relevance whatsoever to chemistry, unfortunately. So yeah. Yeah, I don't know what advice to give you there other than be prepared, stay relaxed, but do try to remember the things that you've rehearsed as good answers to have for these questions. I think, throughout school, I was interested in chemistry. I always wanted to know what things were made from. So that's what sort of stood me in good stead. I knew that I was passionate about understanding what stuff is made from. And hopefully that came through in the interview then.
And I think also the question relates to some non-academic activities that maybe you have done prior to applying to university. Were there any extracurriculars that you were passionate about, or?
I think things are different now. When I was a kid, I came to Oxford in 1992. I grew up in a village in Northern Ireland. There weren't many things going on as extracurricular activities, whereas I look at what my kids do today and like, oh my God, how do they fit it all in? But So 17-year-olds today do a lot more than I did when I was a 17-year-old. So I don't think we can compare the two. So I didn't have much really to say as extracurricular activities, other than the fact that I enjoyed some sports. I was a very keen cyclist, things like that. But yeah, no. I think just the fact that I was an academic kid, I liked studying. That's what was the sort of main thing in my favor, I suppose.
Yeah, that makes sense. Um, it must be interesting finding out more about new research and technology such as genome therapy. How do you find out about these topics?
Yeah, though that's as I am doing my job, I have to be quite disciplined sometimes because I will start reading. I must admit, one of the first things I do in the morning when I turn on my computer is go to BBC News, and I go to the science page on the BBC News website just to see what's happening there. And I could very easily get distracted and just spend an hour reading interesting news, which isn't really part of my day job. So nevertheless, I do just read around the subject. And the way I am disciplined is that so at this time of every year, so I have just written my production plan for 2023. So these are the reports we will produce next year. I will create an Excel spreadsheet now for each of those reports, so that if I happen to read an interesting news article and I think, oh, that'll be interesting when we come to do our update on lithium-ion battery materials next year, I'll just copy and paste the URL, put it in that spreadsheet, so I know when we come to start that report, there'll be a list of a lot of interesting things that have happened over the past year in that industry, so we can kind of start working that report, hit the ground running, if you like. So that stops me from spending too much time reading those articles when I first come across them. Think, okay, file that for later. We can read it when it's useful, or the analyst can read it when they're writing the report. So that's kind of what I do to stop myself getting too distracted by the news. But part of my job is just to keep up to date with what's happening in the world, and how that relates to future demand for chemicals.
Yeah. And I also had another question because you mentioned in writing reports or articles about photovoltaic cells or lithium-ion batteries, and I was wondering whether there are any researchers or research institutions that the company that you're working for collaborates with.
So when we do our research, so yeah, our reports are very much focused on quantifying, how big is the market today? So how many hundreds of millions of dollars or billions of dollars are spent buying the materials you need to produce solar panels? And we get that from the companies who supply the materials. Sometimes we will speak to the companies on the demand side of that relationship. So the buyers, so the people making the solar panels, will sometimes ask them about their purchasing patterns as well. The academic researchers coming up with the new materials, not so much. So on the example of the solar panels, 95% of solar panels today are still standard crystalline silicon. So people are looking at perovskite and thin film and other technologies as potentially ways of making solar panels in the future. And yes, we looked into perovskite, and there's a lot of researchers out there doing academic research on perovskite solar cells. But chances are they're not going to be commercialized for at least 10 years. So my report's only quantifying future demand for the materials for the next 10 years. So perovskite's interesting, but it's not going to affect the commercial market for the next 5 or 10 years. So it won't really feature in our report. But yeah, there's still a lot of cool research going on. The Tech Vision team, so when I showed that slide with the 12 business units of Frost & Sullivan, one of the ones on the right-hand side, Tech Vision, their remit is to look at new patents that are being logged either by academic institutions or by commercial companies as well. So they track patents and new technology development in some of these areas. So they look a lot more at that side of things, and what sort of academic institutes are researching these areas.
Yeah. And also, have you also thought about doing or continuing doing academic research after you finished your PhD, or you were completely sure about going for a job in consultancy?
I personally was pretty sure I didn't want to continue with academic research, just because it wasn't for me. You know, I think I loved doing my PhD. I really, really did. But it seemed to me that to go on and have a career in academia, um, it was very entrepreneurial. You know, you find your own area you want to research in, you go and find grants, you put in a proposal to the head of department to say, I would like to do research on this. Yeah, very entrepreneurial. And I didn't really see myself as an entrepreneurial person, which is why I wanted to get a job as an analyst for a company. Um, and again, you know, the workplace is changing. You know, when I look at people joining the workspace today, a lot more young people now want to have more of an entrepreneurial career. So we find it harder to find analysts who want to have a long-term career in a company. So you know, we've signed up with an agency that has a vast global portfolio of freelancers that we can just tap into when we need to. So the one we use is called Upwork. And so, you know, if you register as a freelancer on Upwork, companies like us will come and say, oh, we need someone to do a day's work, a week's worth, 300 hours a year, whatever, on this project. And they will find us someone to do that work for us. So, yeah, I think, as I said, young people today are much more keen on that sort of entrepreneurial route, whether that is in academia or in my sort of field as well. So yeah, that's why I didn't go down the academic route, basically.
Yeah, that makes sense. Someone says it really sounds like you look at varied and interesting topics. If it's not too hard to pin down, what's the best thing about your job, the thing that gets you up in the morning?
Yeah, it's just the thought that I will find out something new every day. Now, maybe it's getting harder to find those new things because I primarily manage our portfolio of published research, so it's very much up to me to decide what topics we write reports on. If I was to work on the consulting side of the business, you get more surprises because clients come to you and say, hey, we need a project on this, and you get exposed to stuff you've never done before much more frequently. The downside of that is it's much harder to be an expert, and yeah, I like seeing myself as an expert in a field, so that's why I prefer managing the research side of the business, where I can build up a portfolio of knowledge to become that expert. So yeah, that's why I've ended up mostly on that side. But we still get our clients, you know, the people who subscribe to our research, coming to us. They've read a report and they said, "Oh, read this really interesting report that you did." So we had one the other day. The nutrition team wrote a report on bone and joint health ingredients. So you know what supplements and what ingredients can go into processed food that provide bone and joint health benefits. And they said, "Oh, an interesting report, but I see you haven't put something in. I can't remember the Latin name, but basically it was from the frankincense plant. Apparently, there's some extract from that that can help with joint inflammation." I'm like, "Oh no, we didn't put that in the report, but thanks for the tip. So next time we do an update on that report, maybe we'll look into that as an ingredient as well." So we're always getting queries from clients that challenge our thoughts on what are the important products to cover, and are always providing us with new ideas on what we should be doing our market studies on.
Thank you very much, Brian, for your answer. We only have a few minutes left before we will close this session. So I'm going to ask for any last questions for Brian today.
For my
Um,
voice goes.
and in the meantime, I just quickly wanted to check with you. Is it possible to get a job in consultancy even if you don't have a PhD right after you graduated from Oxford after your Part 2 project?
Yeah, I'd say it would be. When I look at the analysts we have brought on board over the years at Frost and Sullivan, Most of them have come in having either done a PhD or had a bit of workplace experience beforehand. We haven't brought in many people straight from their first degree. So yeah, I'd say go explore other areas. We don't really do internships ourselves, unfortunately, although maybe I should speak to our HR team and see if there are any opportunities for us to bring some interns in, which could be really interesting for people like yourself, Sandra, and also for us as well to get someone in to do some work for us. So yeah, we tend to bring in people that have a bit of other experience first. Certainly when I finished my first degree, I didn't know what I wanted to do with my career yet. So the PhD was partly because I liked the idea of a PhD, but also, if I must admit, partly because I didn't know what else to do yet. Whereas after my PhD and the other experiences I got from that, I was more mature as a person. I'd done some work for Merck in their pilot plant. I'd been to conferences. I'd done the business skills course. I was just much more able to decide what I wanted to do with my life then.
Thank you. Thank you very much, Brian, for your presentation today and for answering all our questions and giving an insight into your journey from Oxford to your current job. I can see there are no other questions left, so I would just like to thank everyone for attending the session today. You will be able to find the recording of this talk in a couple of days on the website, and also please check the website for any other outreach events that might interest you. I would like to thank you again for joining us, and thank you, of course, to our guest Brian today. I would say just have a lovely day, and I hope to see you in other events as well.
Thank you, Sandra. Lovely to speak to everyone. Thank you.